What's going on? Okay. So I just wanted to provide a general introduction for those of you who do not know me. My name is Josh, and this is the Invoke Reverse Engineering stream. We do malware analysis training. So I just wanted to show you because I did some changes to our UI stuff. This is our main website, training.invokere.com. And we have a course called Introduction to Malware Binary Triage. And this basically gives you an introduction to reverse engineering and analyzing malware binaries. And so this page was getting really cluttered with a bunch of the different UI components and our new pricing model and stuff like that. So I broke this out into our pricing page now. So this is where the course prices can be found. So we have a free tier. So if you just want to register and check out the course, you can. If you're a student, we provide student discounts, and we also provide discounts for individual researchers. So if you're interested, you can check it out here. I'll throw the link in the chat. But big shout out. We also got a number of different testimonials from some learners that recently finished this. So yeah, shout out to Jonas and Ken. We got a couple more that I need to add up there, but pretty cool. And then this is also our FAQ is on the pricing page now as well. So this kind of stuff funds, like we're using Sidekick today, so funds from this course go directly into these streams by enabling us to use stuff like headless Binja and Sidekick. So cool. So that's kind of that stuff out of the way. So I just wanted to provide a general overview as to what we were doing last time. So thus far, we've been analyzing a Qakbot packer, and that packer has a first stage that will essentially decrypt a shellcode stage, and then that will map an executable into memory and execute it. That portable executable will then map a second portable executable that's plain text, and then it will execute that. And then finally, we have a Qakbot PE that's mapped into memory and executed. So what we've done thus far is just let me make sure the chat is up. One sec. Cool. So what we've done thus far is we've basically written automation for this first stage, and we've made it generic enough so that it works on multiple samples. There is a bug that we're going to fix as a part of the stream that I noticed when I was doing some testing this week. But we've basically gotten to this final Qakbot stage in a headless automated fashion using the Binary Ninja API to extract all the attributes to get to that stage. And then we also have made use of Binary Refinery, which is a really cool project. So instead of me talking through this, I could look at our notes. So if you go to GitHub, invoke-re, and then we look at the stream notes here. I wrote this all up. So basically what I've explained thus far. And then last stream, we basically cleaned up our code in order to do the recursive technique. So we're enumerating functions recursively to identify the unpacking functions that we needed. We confirmed that we could use Binary Refinery to basically extract the final portable executable from the shellcode that we're decrypting using Binary Ninja. And then Nord also gave us a cool tool to look at called Memory Mirror. So I didn't know at the time because we were busy working on stuff, but this is actually a pretty cool tool because it's written in Rust. And from what I can tell, this will actually effectively dump every memory region associated with a particular process and enable you to analyze it. So this is kind of similar to PE sieve. but it's all written in Rust, which I'm a big fan of because I'm starting to learn Rust, and the more tools that we could start writing in Rust, the better. So yeah, effectively it freezes the process by suspending all threads, enumerates all the modules and stuff like that. So pretty cool project. So that's in our stream notes as well. Next course is going to be program analysis. Zod, what do you mean exactly? Let's keep going in the meantime. And then, so when we actually wrote our unpacker, we discovered a interesting variant of this unpacking workflow here, or infection chain is what it's commonly referred to as. And this infection chain eventually leads to an unidentified DLL in memory. So we actually started analyzing that infection chain because it was quite interesting. It was using what are called indirect syscalls. So it was basically copying low-level APIs. So if I go back to the course, so we do actually do, let me just give a general overview. So we don't only do triage. So triage is kind of just like a general term that's used in industry. But effectively, we go through like every facet of malware reverse engineering. We look at the portable executable format. We look at x86 assembly. We look at static analysis. So in this particular instance, we start with binaries that I created, just really example basic binaries. And then we analyze those using IDA and dnspy. So IDA for the regular binary portable executables, and then we use dnspy for analyzing .NET. We do .NET as well. Just because effectively, from what I've seen in my time reverse engineering, which has been a while, we primarily see a lot of .NET malware, and then a lot of native binaries that are written in C and C++ and Delphi and stuff like that. And then we also go over dynamic analysis, of course, and we use x64 debug, and then we use the debugging functionality in dnspy. And then we also go over network monitoring, so how to perform passive network monitoring of samples, and we use inetsim and fakenet ng. And then through at this point, there's like a midterm exam basically to test all of your knowledge thus far. Every module and lab has a series of questionnaires that you can use to kind of solidify your knowledge as you're going. And then we get into obfuscation, so various obfuscation techniques that are employed by malware. And then unpacking and process injection. So we go through run PE injection or process hollowing, which is a very common process injection technique. And I show you how to unpack those. And then reflective DLL injection as well, which is another very common process injection technique. And then we go into analyzing generically packed malware using a number of generic mechanisms to dynamically unpack malware. And then, of course, we go into writing YAR signatures and then performing what I call comparative analysis, which is essentially comparing different malware binaries using, in this scenario, we use bindiff. And then we talk about automating binary triage. And finally, once you reach the end, you can do the final exam. And if you complete the final exam, then you get a certificate of completion. So the students that we've been, or that I mentioned earlier, have completed the course and gotten that certificate. So I forgot to link that in the chat. So I'll just do that right now if you want to check it out more. And again, you can register and get like 3 modules for free. You don't have to pay anything if you just want to check out some of the content. Hopefully that helps. And then this is kind of the current stage of our automation. So this is the unpacking script that I was talking about. This is kind of Oh yeah, also I should mention all this stuff is on YouTube. So we have a YouTube channel. And this covers all the past streams as well. Hey Donald, how's it going? Yeah, so thanks again for the testimonial. That's awesome. And again, congrats on completing the course. So yeah, so if you want to check out the past streams, they're there. But basically what the script is doing, so I'll just go over it really quick, just because I don't want to spend too much time on the unpacking stuff since it's effectively completed, but I do want to fix a bug that I found in there. We have a visitor function that will essentially go through, sorry, let me back up. So for those of you who are not familiar with Binary Ninja, Binja, or a lot of people call it Binja, including me, because it's less syllables, but basically it's a reverse engineering suite very similar to IDA that provides some really good functionality out of the box and a really good API. So I'm trying to get better at using Binary Ninja, so I thought I would do a bunch of streams on it, which is what we've been doing thus far. And to be honest, there's not a ton of malware reverse engineering content out there right now with Binary Ninja. There's a few really cool blogs that people have done, but especially with the automation, there's not a ton of resources. And so just to give you kind of a glimpse as to what the automation looks like. So I'm just going to open the Python console here. And so this is that original packer that I was talking about that we wrote some automation for. But if I wanted to get, say, the current, okay, so if I wanted to get a reference to the current function, I can just use current function. And then Binary Ninja has what's called BNILs, or Binary Ninja Intermediate Language Representations. And so these are very similar to something that you would see in like Ghidra or IDA's hex arrays, where you have a disassembly. So we have a disassembly on the right-hand side here, which is x86 Intel assembly. And then, or this is x86 64 because it's 64-bit, but that's just the extension of the Intel x86 language. And then we have the high-level representation of this code. So Binja lifts this into various levels of intermediate languages. So it has a low-level IL. So as you can see, it's kind of one step above the disassembly. Then there's a medium-level IL. And then most recently, they've created high-level IL. So this is basically the closest that you can get to a pseudo representation of source code for the binary. And yeah, so this is basically that unpacker function that I was talking about, which unpacks and executes the first shellcode stage. And so just to show you kind of what the API looks like, we can do something like current function .hlil, and then that gives us the high-level intermediate language for this particular function. And then I can do instructions, and that creates a generator. So if I wanted a list of all the instructions, I can create a list. And then let's say I wanted to select a particular instruction. I could iterate over this list and select one. But for the sake of simplicity, I can use my cursor and select a location within the high-level IL. And then I can do something like current HLIL. And then I can do something like tokens. Okay, current IL instruction is what I meant to do. And then tokens, still getting used to the API. And then, so this alphabet is actually the XOR key that's decrypting the shellcode within this first stage packer. So say we wanted to grab that in an automated fashion, then I could do like tokens for, I think, what index is this at? I did like the exact same thing at the start of the last stream, but I just want to show you how the API works. So yeah, at index 6, and then we can grab that from the high-level intermediate language representation pretty easily. Yeah, Zod, I would say representations are quite different, simply because they're using completely different intermediate language engines. So IDA, for instance, uses their own bitcode representation, I believe they call it. And same with Ghidra and all of the other reverse engineering suites. They basically have their own intermediate language representation that they use to lift the disassembly into higher and higher levels of representation and abstraction. So yeah, I would say it's quite different. And then you might notice that there's like kind of weird syntax. Like you have, or I think I'm just, it's alien to me simply because I've been using IDA for so long, but you have like 0xtend_q. I'm just going to do, sorry, I just need to adjust my firewall for Visual Studio Code. You can do like, or it says 0xtend_q, which basically means it's zero extending the q word, which if you're not used to this syntax, it might look weird. So like an sxd.d is like a sign extend d word, for example. And then if I go to, but they also have a pseudo C representation. So this looks a lot more like IDA, where you have a pseudo C-like representation. So those casts that I was talking about earlier, they get transformed into a like unsigned 64T, which is essentially like a 64-bit integer cast. So basically that's kind of how their high level representation gets represented in C. I find it's a little bit more readable once you get used to these casts, just because it doesn't take up so much room. But anyways, I'm getting into kind of the weeds here, but hopefully that helps. Okay, so basically what we did is we wanted to automatically extract this XOR key, and then this shellcode is stored within a resource. So that resource is extracted using these dynamically resolved resource functions, and then it's decrypted and written to this virtually allocated memory segment, and then executed. So what we wanted to do is get the resource identifier that was used to extract the encrypted shellcode. Then we extracted the resource using PE file, and then we decrypted it. So if I go back to the code here, and I'm going to show you some new code I wrote. So, okay, so we have the extract resource function, which is basically extracting the resource using PE file. And then we have the resource data that's extracted and returned. And then we have so the visitor function that I was kind of alluding to earlier before I kind of backed up and explained to you how all this stuff works. This will basically recursively enumerate each high-level IL instruction within the Binary Ninja database, and then it will classify them based on various things. So we have let's see here, we have this is_instance call. And then this is looking for, so this is all Binary Ninja API stuff, but this is basically looking for a local call. So it's looking for this local call to built-in string copy. So that's an intrinsic that's created by Binary Ninja. And then once it finds that, it makes sure it has more than one parameter, and that the text of that instruction of the first token is built-in string copy. And then we say that we found a string copy. And then basically we grab the key. We get the instruction for the resource identifier, so this LP name here, and then we assign that to this resource ID variable, and then we call the extract resource function that I just mentioned earlier using PE file, and then we call this carve PE function here. So if we look at this, basically I stole some code from the Binary Refinery project. After I did all of this and kind of tried to use it in this hacky way, Rattle was kind enough to respond to me on Twitter. And he said I could have done this in way less code based on his super cool representation in Python. So I'll probably simplify this later, but we don't have to use that. We don't have to do that on this stream simply because it's just, oh, you're here. Hey, how's it going? It was kindness, not advertising. Yeah, so no, not at all. I think it's so cool how we can all work on projects together and improve them. Like the first stream, Jordan was on here from Binary Ninja, or from Vector 35, who creates Binary Ninja, and he was helping me, and then you were helping me on Twitter afterwards. So I think the community's amazing. So, okay, so once we extract, so basically, since they're plain text, we can actually carve the final PE from the first PE. So basically, we'll basically use this while loop to find the second portable executable and then carve that. And then we pass back all of the carved portable executables from the first shellcode segment. And then we basically provide that as the Qakbot executable and then write it to qakbot.dll. So just to show you this in action, let me pull up my automation here. So, okay, just to give you some background, again, more background. So this is using the Binary Ninja Python API. And I have Binary Ninja installed headlessly on this Linux box that I have that's separate, that I just use as like a dev environment for stuff like this. And basically I have all of the malware on this box as well. So we have our extract qakbot.py, and then we can run it against the first sample that we had. Oh wait, I didn't initialize my environment. One sec, my Python environment. And I'll show you the bug in the other sample in a sec here. So it's there's not a whole lot of verbose output, as you can see, but I promise it's doing stuff. There we go. Yeah, bsend packet. The headless version is only available in commercial. Okay, so we extracted the key. We decrypted the shellcode, and then we found 2 valid portable executables, and then we've written the final Qakbot DLL to qakbot.dll here. So the other sample that we were first analyzing that I'll show you that there's a bug in, and we'll fix that bug right now, is this one. It's like 780. Okay, so we have a couple things that happened here. So we have a string copy that was found, but it wasn't the correct one. And then we weren't able to obviously extract the valid resource, etc. So we just have to, so I did have a heuristic for fixing this that I ended up removing because of the third sample we found, but I am going to add another heuristic here just to make sure it works. So we can do a couple things. We could probably just say, like, let's see here. So where to find the string copy? Oh, we're not printing out the address. That's fine. So we could probably just say, where is it failing here? High level IL. None type is not iterable. 104. Okay, so we're failing at the XOR step. So I could just like wrap this in a try catch and then just continue, because we're essentially going to recursively eventually hit the correct string copy. So let's just do that. Oh god, the stupid AI is trying to get in my way. Hi, this is my first time watching your stream. Not sure if you've worked with Ghidra or IDA previously, but out of these tools, which are you liking more? So hold on, I'll answer that question in 2 seconds because I'm just going to fix this and then. Okay, so we're going to do an accept pass, and basically we don't want to return false because that will stop the recursion from occurring. I guess we could just return true, but this will basically serve the same purpose. So this should fix that. Yeah, so to answer your question, like any tool used in information security, a lot of them have their advantages and disadvantages. So there's a lot of string copy. Maybe I should improve the heuristic. There we go. So, okay, that fixed it. So for example, like I've been using IDA for 10 plus years analyzing malware. I think the biggest barrier to entry for IDA is the price for most people. They've gotten a little bit better with offerings like IDA Home, and then offering things like the cloud decompiler and stuff like that, which is super awesome. But yeah, I've been using IDA for forever. One thing that I've been struggling with, and why I like Binary Ninja so much, is their API. So it's essentially C++ bindings for Python. And because of that, there's very little Pythonic about it, and it makes using it more difficult. And then out of the box, like if you want multiple architectures, like say if I wanted to analyze ARM, then IDA, you would have to buy separate license for that, etc. And then if you want the offline decompiler, so if you don't want all of your bytes going to the cloud for a particular function, then you would need to buy a separate Hexarrays license, which is also an additional cost. So for most folks, like a lot of people in the OA Labs Discord and on our Discord, etc., the cost is mostly prohibitive. And then Ghidra has come out, which I'm a pretty big fan of. I like using Ghidra for the most part. I'm not really super used to the bindings and stuff like that, so I'm really slow with Ghidra. So I haven't used it a ton, but I have used it in the past. Like I have a blog post on using Ghidra for some stuff on my old blog. And what's awesome about Ghidra is it has support for a huge plethora of different architectures, including things like ARM and x86, and it's all completely free and open source. So the only downside that I really see to Ghidra is using their API. I used to write Java in like university, but I haven't written a ton of Java since, and so I haven't really used their API that much. Mostly because I've had access to Binary Ninja and IDA. So hopefully that makes sense. But yeah, all of them have their advantages and disadvantages. I do find the decompiler in IDA to be one of the best, but like Binja's kind of gotten very close as recent with a lot of their 4.0 changes. And then they're kind of light years ahead with their API, so, and their headless API, and it's way faster. So JT, yeah, their licensing is definitely cost prohibitive and stuff like that. I think they primarily rely on commercial licenses for most of their revenue streams. But yeah, I agree. It's like if you look at Binja, and I did this last stream too, but it's worth looking at. Like their licenses for non-commercial use is like pretty cheap, and then if you're a student, it's like dirt cheap, like $75. And then obviously I think you have to renew on an annual basis. Like I have this commercial license that I renew on an annual basis. Funnily enough, when I first bought my commercial Binja license, I had like some Bitcoin that was left over from when I was like, I don't know, like 2013. And I was able to use it to buy that license. So I thought that was really funny and a good use of Bitcoin instead of trying to convert it back into dollars. Half off renewal. Oh, cool. I didn't know that. Yeah, like when I renew my commercial license, it's not at this price. It's discounted. I can't remember exactly what it is, but you're not renewing at that price either. Okay, so I know, sorry, that's a lot of talking about reverse engineering suites, but okay, so let's continue looking at our code and what we just did. So basically I just added a try catch block for string functions that we don't want to use. I had a length that like, so obviously these strings are tiny, right? Like ERCP. And the try catch block like isn't a great mechanism to stop this from happening, but yeah, no worries. But then we get our final portable executable here. So last stream we were analyzing that 64-bit, that sample that was doing the indirect syscalls. So I thought we could wrap up our Qakbot automation in order to kind of tie that up in a bow and then have our automation for Qakbot analysis, and then work on that indirect syscall sample in a later stream, maybe using IDA or something like that. Just because since this stream was kind of centered around Qakbot, I wanted to finish the Qakbot analysis. So if you watch the first stream on YouTube, or if you were there live, you'll know that. So if we go back here, you'll know that I was looking at these dynamic function resolution functions. So on that stream, I was basically trying to figure out how all this worked, and it was getting pretty late in the stream, so we didn't get a lot of answers that stream, but I went back and analyzed this since then, and I basically figured out how all this dynamic function resolution is working. So when this MW resolve function table function is called, it's passed a global here, and it's passed the size of the function table that we want to resolve, spoiler alert, and then an offset into this global. This is the function table that we want to resolve. And then this offset is just an offset into a buffer that has encrypted DLL names. So I'll show you what that looks like. So if we go into the MW resolve function table here, we have the hash table address. So if I go to one that's not resolved already, it's already resolved. Let me go back. Okay. Sorry, I have Sidekick that I just set up too. So I don't know what Sidekick is doing in the background, but it's doing a bunch of stuff using machine learning, or using the like generative AI stuff. So we'll look at that later. But it's every time I visit a function, it's suggesting things. Okay, so yeah, okay. So this is an unresolved function table. So basically, what these are is their function hashes. So I can't remember. Okay, so if I wanted to make this into like an integer, so these are actually all, or no, these might be 32-bit actually. I think they are. Yeah, because they're CRC32, which I'll show you how I figured that out too. But basically, so it's number 4. So these are all hashes that are used to dynamically resolve functions. So if we go back here, then this function first, it takes that module CT offset that I mentioned as a parameter, and then it moves that into a local variable that I've just called module CT offset modified, because it multiplies it by 21. And then it uses, so this is all, these are just all encrypted DLL names. And then basically all it does is it uses that offset that I just calculated by multiplying it by 21. And then it uses that offset into that global data to get the module bytes. And then each byte is just XORed with this D word. So if you look at the code here, all this is doing, all these calculations make it kind of look more complicated than it is. But basically this is just iterating over each byte in the encrypted DLL name and then decrypting it with each byte from this D word. Okay, so if I go to our code here that I wrote, I can show you how this all works. So I'm just going to grab this, and I'm just going to put it into snippets just so I can kind of show you what the code looks like. But basically, we want to automate all of this function resolution using Binary Ninja. For those of you who are from like the OA Labs Discord, etc., you would know that you can use hashdb for this. But basically, we want to do this all ourselves in Binary Ninja, just kind of for the sake of demonstrating that it's possible. And there might be some of you who have to work in like offline areas, etc., who don't always have access to something like hashdb. So, okay, so if we do a new snippet here, let's just call it Qakbot. Obfuscation demo. Then we have, this is basically going to acquire, hold on, I'm just going to, let me get all this code in here. I'll walk through it. And let me know if you have any questions as well while I'm doing this. Okay, we should be good to go here. So basically all this does is it goes to this function. So this is grabbing that global encrypted module named data using bv.read. So BV just stands for the binary view, so the Binary Ninja binary view. And then this will basically unpack this key that we saw earlier into these 4 bytes. And then this will basically pass all of this to resolve hash tables. So let's see here. Okay, and then once we're in resolved hash tables, it will basically get the function at the resolution address that we're passing here. So that's this guy. So if I go to, oops, that's not what we want. Okay, so that's this MW resolve function table. If we put that, we pass that to this function, and basically it gets the function at that address, and then it'll get all of the call sites. So if I do this, for example, so if I get all the functions at that address, or sorry, if I get the function at that address, and then do, let's see, what was the code? Caller sites. So if I do caller sites, then this is all the locations in which this function resolution function, I should probably call it something else because it's kind of confusing. This is all the locations that this MW resolve function table function is called. So we enumerate those in our little script here. Then again, we're getting the high level IL for each of those, for each of the calls, or sorry, we're getting all of the data basically that we need in order to decrypt those DLL names. And then we perform the decryption by calling this decrypt mod name. So let me get that function as well. Okay. And then let's get they changed this in 4.0 and I don't know how to get the toggle log. Where's the logs? Okay, so I'm just gonna make this bigger. Okay, so let's go back to our script. Okay, so, and then basically all this function does is it acquires all of the data that we need to decrypt, and then it decrypts it using that XOR key. Okay, so then if I hit run, we got an exception. Let's see where we're index out of range. Sorry, I'm trying to like basically, this is all working headlessly. So I'm basically just copying my code across and some of it might not work out of the box. Okay, let me instead of copying this piece by piece, I'm just going to copy the whole thing. And then we're just going to do this. Okay. So this should work. Get symbols of type. Oh yeah, because this is going to do, hold on, we don't want to do everything yet. So 2 seconds here. Okay, let me get rid of all this for now. We're getting the same exception. Okay, hold on. 12. Offset mod. Let me just make sure this is working locally. Because maybe we'll just jump ahead. Yeah, it's all working locally. So what I might do instead of trying this in the UI, because this is already written, so we really don't need to. I'll just kind of jump ahead here. So what I'll do is just show you what this looks like. Okay. So this is essentially just decrypting all those DLLs that are stored in that global ciphertext and then showing them here. So, but what hashing algorithm, so okay, let me back up. So basically what this malware is doing is it uses this dynamic function resolution, or this malware resolve hash table function, to basically iterate over the address of names for each module. So basically it'll decrypt the DLL name. So say it'll find kernel32.dll, and then it'll acquire the, it'll walk the image export directory within that portable executable header. It'll grab the address of names, and then it'll basically iterate over each of those names and then perform this hashing function on each of those function names. So say we go to this, we need to identify what hashing algorithm this is, right? So again, that was one thing that I was doing at the end of the first stream, but we didn't quite get there until the end. Well, we hadn't identified this type of hashing algorithm yet. So I just called this hash material, but if we go into this hash material location, there's this data, right? So I didn't know what data this was at the time, but if I change this to D words, so if I press 4, I'm getting better at using the Binja hotkeys and stuff. So if I Google one of these D words, then we can see this is a pre-computed CRC32 value. So based on this being a pre-computed CRC32 value, we can assume that this hash material is a part of the CRC32 algorithm. So obviously then after that I confirmed that, but they are doing one modification. Sorry, I just drank some coffee and struggling here. So if we do, so the result of that CRC32 hashing algorithm is modified by XORing it. So this is just a really basic technique used to modify the hashes that are stored within malware that are used to dynamically resolve functions, so they're not the same across every piece of malware and can be signatured on and stuff like that. And this is covered in HashDB as well. But if we wanted to implement that ourselves, then this is what this would look like in Binary Ninja. So this had never really been done before that I've seen, in that basically what's really cool about Binary Ninja being headless, I'm just going to make this a bit bigger actually because it's kind of small. What's really cool about Binary Ninja being headless is we can effectively process multiple portable executables using Binary Ninja on the fly. So what I did is programmatically enumerate these DLLs. So I copied these DLLs onto my box here. So if I go to dependencies, I copied this from a Windows machine that I have. And then once I decrypt that DLL name, I'll actually load it using Binary Ninja. And then I will essentially enumerate the symbols within with Binary Ninja after it's been loaded. And then I will hash those using that CRC32 algorithm to see if they match our hashing tables. So I'll get into kind of how the hashing tables functionality works as well. But essentially what this is doing, this isn't super obvious, but basically if I print out these symbols, and I print out, so export functions for, so this is going to be DLL name. So for that DLL name, and then we have, okay, and I'm going to get rid of that other print that we had. So if you saw that suggestion that was just made, I'm using Copilot as well. So I'm trying all of the AI tools in my workflow just because, you know, if we do get partially replaced by AI, I want to know how to use it like properly and quickly. Okay, so if we run that, then unsurprisingly, we get a giant list of functions. But these are essentially all of the export functions that are being walked by the malware and that are being hashed. So just to back up and for this to make more sense, I open each DLL dependency that we're decrypting on the fly. And then I open that using this binary view type PE open. And then, so what's nice about open is it won't process the DLL, but it'll give us the symbol metadata that we need in order to enumerate the export functions. And then we basically hash those and then put them into these hashing tables. So hopefully that makes sense. Okay, so I know that was a lot of talking. How's everybody doing? I know it's probably not super exciting just me going over my code that I already wrote before stream, but I just want to make sure everybody understands what's going on. And then, okay, so then the next thing that we want to look at is matching those hashes to those hash tables that I showed you earlier. So if I go to these, go back here, and then, so if I resolve this using 8. So basically what we want to do is we want to enumerate all of those DLLs, hash them using, oh wait, these should be 32-bit, not 64. Hash them using CRC32. And then we want to match these, let's see. Then we want to match them against these hashes. So the way we can do that is if we enumerate all of the function calls to MW resolve function table, and then if we get the hashing table for each of those and their size, then we can iterate over each hashing table and then resolve each of those hashing functions. So if I go back to my code here, then we have our table being generated, and then we have, so basically all I'm doing is I'm acquiring those hash tables that are being passed to that function using the hash table function address and the hash table size. And then I'm basically getting all of those 32-bit integers by using this unpack function here, and then this unpack call, and then basically I iterate over those and then look at the DLL hashes that we've computed. Okay, so then let's see what that looks like now. So I have all these print statements that I should really make real logging, but that's okay. Okay. Oh wait, let me get rid of that other print because there's way too much stuff going on. This one. Okay. Okay, so basically this is doing what I was describing earlier, or this is showing this in action, in that we're identifying the hash within a particular DLL and then writing that to our table. But it's not showing the actual function name, so I'm going to change that. Found func name. All right, cool. So these are all of the functions that are being dynamically resolved by the malware, and then set into those hashing tables. So for those of you who have done a lot of malware analysis in the past, so let me make this a little bit bigger, you will recognize a lot of these functions that are commonly used by malware. So I'm just going to scroll to the top here. We have like load library functions. We have write process memory, which is commonly used for process injection. We have read process memory. We have things like, again, resource stuff that it's probably using for things. So for functions that I could not find, then I'm just putting in these unc placements here. I need to figure out why that is, but I think based on dynamic analysis that I also performed, I think it's just, these are just invalid entries. Then we have a lot of NT functions, which are also recovered, which is interesting. We have a number of net API functions that also did not work, so I should probably figure out why that is, but that's okay for right now. We have a bunch of registry functions and service functions that are resolved. We have a bunch of encryption functions, which are probably what we're going to look at first, because there's a bunch of strings and stuff that we still need to deobfuscate in the sample. Then we have like string comparison stuff. We have a bunch of Internet Open A and HTTP related functionality. So this is likely related to their command and control functionality. So we want to look at that. We have obtain user agent strings. So this is probably used with that HTTP functionality. We have crypt import public key info. So they might be using some RSA or public key encryption in their command and control communications or in another area. Crypt unprotect data, also very interesting, stuff like that. So now comes the task of how do we get these resolved functions into the function tables in our Binary Ninja database so they're like nicely displayed in the UI. So if we look back here at these calls, so for example, this call to MW resolve function table, we have a result that's assigned into these globals. So if we look at these global values, these are referenced throughout the sample. So in this cross references section on the left-hand side here, these are referenced throughout the sample. So if we look at this one, then we can see a relative offset from this pointer is being dereferenced, and then that is being called. So if we look at these brackets are kind of confusing, but if we look on the right hand side here, we can basically see in the disassembly that a call to this keyword is made. So what that tells us is that this relative call indicates that this is a pointer that's being resolved, and this pointer has relative values that point to function addresses that are being dereferenced and then called. So what that tells me is that we need to populate these, or we need to assign these pointers to what are effectively to offset values that map to our resolved functions. So the easiest way that I found to do that in Binary Ninja is to use structures. And by that, I mean like structures in the C sense. And so what we can do is basically create a structure on the fly using these resolved functions, and then import that structure into Binary Ninja, and then apply these pointers as effectively being pointers to those structures. And then when they're called with these relative offsets, we'll actually get the function name to that. Okay, so I know that was kind of a lot of high level, not high level, but theory as to why these are function calls in a function table, etc. But hopefully that makes sense. Once we get the structures imported and they're assigned to these function tables, it'll be a lot more obvious what I'm talking about, because right now it might not be. So in order for us to dynamically generate those structures, we can do that using code programmatically. So I have this generate header function that we can use to essentially dynamically generate those structures. So what I've done is basically just called these struct hashes, hash table address, and then for each entry within the struct, we're basically outputting a int64 t value that maps to our function name. So if we rerun this, I'm gonna get rid of all these other print statements because we don't need them. We don't need these either. Okay, that should be good. Okay, so let's let that run. How's everyone doing? Are you bored? Is this okay? All right, we'll keep going. Okay, so if we look at one of these structures, thumbs up. Okay. So if we look at one of these structures that we just dynamically produced, we can see a few things. So first we have, I know this is kind of hard to read. Maybe I'll just open it. I didn't new line them, but I probably should have. Do you want to install PowerShell? No. So this is what the structure looks like when it's prettified. And basically we're just creating a 64-bit integer struct member for each of those for each of those resolved function hashes. Okay, so if we want to import all of these into Binary Ninja, we can actually use this types table here. So I did this ahead of time, kind of like a cooking show, but I'm going to show you exactly everything I did. So we can do, let me back up. So if you right click here, you can actually do create types from C source. And then I'm going to copy all of those structures that I created and then paste them into this window. Okay. And then click create. And it's just going to ask if I want to overwrite these because they're already created, but that's okay. And then now on the left-hand side, we can see all of the functions that have been created. So, oh, it's hidden here. I wanted this window. Okay, so now we have each of these structures in our Binary Ninja window here. And these have effectively been imported into the Binary Ninja database. And then we can actually assign these to those pointers. So this is kind of tedious. I kind of wanted to see if we could actually get I'm just trying to think. Like, I wonder how hard it would be to like programmatically assign these pointers to each of those data types. I'll do a couple manually and then we'll see, just to kind of show you what I'm talking about. So if I go to this address, 180001080, 180001080, then we can see this is the function call address for this malware resolve function table. And then the result of this is being assigned to this pointer. So we actually want to change this pointer value to the type. So I'm going to hit Y. And then we want to change this to hashes. This guy here, 1800080, and then make that a pointer. And then just to make this a little bit more readable, we can name this to hashes 1800010. 1080. Okay. And then you might have noticed on the left-hand side here, now if we look at these cross references, okay, so if we look at the cross references for this, then we can see that now these are nice function pointers to actual functions rather than just unresolved functions. Okay, so if we go to like this function, for example, we can see a call is being made to create named pipe, and then usually just to make sure that I'm on the right track for these function hashes that are dynamically resolved, I will search one of these APIs. So if I do create named pipe, then this is 1, 2, 3, 4, 5, 6, 7, 8. This is 8 parameters. So if I go back here, then we can see that this is 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 parameters, right? So these line up as they should. And then these values probably have some meaning in the documentation as well. But we won't mark those up right now simply because we want to finish our other markups for the other function hash tables that we've resolved. Does that make sense? Let me pull up the chat here. Let's continue on with marking these up. So I think this is already marked up, but I'm going to do it again anyways. So we have, or I'm going to go in the order of these imported function addresses here. So I'm just going to go to 180000109B, which is this one here. Okay, so then we'll do this as 109B, and then if we go to 1800018D2, oh, these are the same function? Oh no, those are just the same names. Hold on. Okay, that's right. Sorry, I probably should have marked these up beforehand. Okay, so then I have 90C. How's everybody doing? Sorry, I'll be done this in just a couple minutes here. Maybe not even a minute. It'll get exciting after this, I promise. Okay, then we have 19B3. Okay, and then the 19CF is one that we couldn't resolve, which is fine. Okay, and then we have, oops, I just renamed that. I didn't mean to do that. I wanted to change the actual type. 2A41. I keep getting that rename by accident. 2A41. All right, last one. Okay, so we'll say that, and then if we go to like for this one example, like crypt import public key info, etc. Okay, so the reason we wanted to do all of this is because Windows APIs make our reverse engineering process a million times easier. So we have now if we look at the decompilation and disassembly here, now we have the pointers to all of the functions that are being used by the malware to conduct its functionality. So now that I've marked these up, I'm just going to run to the washroom. Yeah, I'll be back in 2 minutes. Okay, so now that we've analyzed those functions, this is when the real reverse engineering begins, because we have all these marked up functions. So now we can get a better understanding of what's effectively being done within these functions. So usually I like to start at the beginning of the piece of malware in order to get an idea of its overall control flow. So if we go to our DLL entry here, this function is what's going to be executed by the DLL loader at first. So first we have 2 calls to our MW resolve function table call, and then we have this should be marked up as well. Cool. Yeah, we have our first 2 calls here, and then we have a call to 18000DAE4. So let's check that out. Okay, so it's doing find first file, and then it's getting the file data. Okay, so it's performing a heap allocation and zeroing it out. So I just like to mark functions up as I go, even though they're concatenating a string here. So let's say MW heap alloc. So maybe we can just call it append string to heap. And it looks like that's called in a lot of places, so it's probably important. And then that's being passed to, and then there's a sleep here. So I wonder what they're using the find first data for. So let's go to our browser here and check out what that API function does exactly. Okay, so it's searching a directory or subdirectory. Okay. This is called in multiple places. Yeah. Okay, and then we get, so basically this is enumerating some directory, sleeping in between, calling an argument function with each file data found, checking if it's matching, so period, checking if it's not equal to dot path match spec w. So searches, okay, so it's just doing a wildcard match for the first period, and then I really want to know, so this is like some sort of callback function. Oh, so okay, so I'm still struggling with the Binja UI, because I was like, that doesn't make any sense because there's only one argument passed. And it's just because I double clicked on this 18000DAE4, and then we got it, I thought I got dropped into this 18000DB24, but I did not. So have to be careful. But so we have some sort of constant. We can look at this again later because this looks interesting. It's definitely doing some path matching stuff. But DAE4. So we have some sort of constant that's passed to this function. And then we have a return with a call to a bunch of stuff. So if I go to this 18000D880, then we have some other interesting functionality. Okay, so it looks like, okay, so what I did here, I just clicked on, so in 18000D880, this is the first call that's made with all the arguments. And then this function looks like it's doing a whole bunch of interesting stuff. So we have crypt acquire context, crypt create hash, crypt hash data, crypt derive key. So it's deriving a key of some sort. And then setting key parameters for that key. Sorry, the granola bar is not going down smoothly. And then we have crypt encrypt. And then we also have crypt decrypt. So it looks like that this is kind of a generic encryption function. So let's just call this MW MW crypt decrypt data, and then we'll figure out exactly what's going on here. But it looks like this is called in a whole bunch of different places too. But if we go back here, My guess is this is probably performing some string decryption, but let's see if we can figure out exactly how. So if we go back here, we have, so this is called in a whole bunch of different places, right? As well. But if we go back to where we came from the first time, we have this constant. So let's just call this constant, or like integer or whatever. And then that's being passed as the last parameter. So let's call this constant passed. And then let's just double check that's right. Yep. And then that's moved into this R81 variable. So it looks like they're doing some sort of modulus operation. Call it constant. Again, still getting used to the high-level IL syntax. Plus arg1. So if we look at arg1 here, we can see that that's to this big, what is probably ciphertext, this big data block here. So let's call this maybe ciphertext. Okay. And then, so if we go to, so this is looking a lot like that module decryption function that we analyzed, or that I showed you earlier, that I analyzed before the stream. So we have our module, or we have ciphertext, maybe, is that what I called it? Maybe ciphertext. Okay. Then that's appended to this constant, and then that's used in this operation here. So let's say CT const offset or something. So I'm just going to change this to pseudo C because I'm not super familiar. All right, yeah, let's go back to. So it's like a modulus combine. So I'm assuming that just adds them together. Then we have this result that's used with modulus with rx1, and then that's equal to the offset. So I wonder if this is decrypting a bunch of stuff, and then we're just getting the offset this way. Like I wonder if this decrypts the entire string table. Let's see if the other calls to this are similar. All right, let's go back. So let's see what's passed to this function. So we have 0, arg3 through 5, and then this. So let's say offset into dec result. If that is indeed performing a decryption. And then let's see. Oh, right. I think I remember reading about this. So I know Zscaler just did a blog on Qakbot. And I know, yeah, okay. So string obfuscation. And every version of Qakbot since its inception has obfuscated the malware's important strings with a simple XOR algorithm. In later versions of Qakbot, the XOR length was significantly increased, or the XOR key length. Strings were copied to a newly allocated buffer. Okay, and then later on, however, the XOR key is no longer hard-coded in the data section. Instead, the XOR key is encrypted with AES, where the AES key is derived by performing the SHA-256 hash of a buffer. A second buffer contains the AES initialization vector as the first 16 bytes, followed by the AES encrypted XOR key. Okay, so I bet this, what we're looking at here, is probably what we're looking at and it just looks a lot different because of Binja. So if we go to our function here, then let's look up these operations. So we have, just going to make some real estate here. So we have, what's the fastest way to do this? I can put this in a different window. I can switch back and forth. Okay, so then we have the first function that we want to look at is crypt acquire context A. And we have a CSP provider as the first parameter. And I think that can be 0. So the Windows crypto API is like kind of weird in that like it needs a whole bunch of different stuff for it to perform crypto operations. So these type of setup operations are pretty normal to see. So let's just call this container name. It's not needed. So it's the fourth parameter, provider type. So the provider type might not be loaded yet. So yeah, so I was messing around with this last night. And in Binja now, there's these type libraries, right? And it'll load all the type libraries for a particular executable, but I don't think it accounts for DLLs that are dynamically loaded. And then it also doesn't account for some of the other constants that I was seeing. So if I go to the right here, we can look at these provider types, and this is probably, let's see, is there prov in here? No. So I was going to cheat a little bit just because I don't know how to get these types up with IDA, because these are definitely in IDA. So if I go to this function here, and if anybody knows how to get those provider constants into Binja with these type libraries, let me know. I'm going to put on a different song. There you go. Okay, so if I go to this function address, let's get the provider type for this guy. So it was 180010C2. So okay, so this is being simplified, plus 18, that's funny. Should be in the disassembly here. So yes, this is it. Provider RSAAS. Okay, so this is a AES crypto service provider. So I'm just going to create an enum so I don't have to. So I know actually one thing. Okay, for now I'm just going to do these. Nose cam looking good. Hey Sergei, how's it going? Yeah, so I don't know. I wonder if I can figure out how to get this properly in Binja. But okay, crypt create hash. So then this CSP is passed to crypt create hash. So if we look at the docs for that. Hey Leon, how's it going? Leon's also one of the people who finished the Introduction to Malware Binary Triage course, so shout out for that. Okay, so the aug ID, yeah, doing pretty good. We're just looking at this Qakbot stuff. Spent a bunch of the first part of the stream just going over kind of what I'd done off stream. So I basically, here, let me just go back to this real quick. So I basically resolved all these hashing APIs, or all these hashed APIs using Binary Ninja by itself. Created structures and then imported them. And then I assigned these to each of these function pointer addresses. So then we had all the resolved API names. What course? So let me link it just here. So I kind of did a spiel earlier, but it's called Introduction to Malware Binary Triage, and it'll give you a good idea as to what I'm doing right now on a more basic level. This is a little bit more advanced, but basically it just goes into all the reverse engineering steps from the ground up. And yeah, if you want to register, there's like 3 free modules, and then there's other options as well. But yeah, so that's kind of where we're at. Just started analyzing this functionality after we resolved all the dynamically resolved functions. And okay, so crypt, create hash. Let me see if I can, because this is kind of ghetto what I'm doing with IDA. So the types here, add type library. So like, you'd think that they'd be in these crypt DLLs, right? The type information. But then if I search for 800C, then there's no enums that map to those. So I don't know if it's like those aren't in those DLLs, or like what exactly is downloaded from Microsoft. But yeah, pretty weird. Unless it's in a different one. Let's try kernel base. I don't think it's in kernel base, but might as well import all of these. Crypt 32. Yeah, I don't know. Bcrypt. Look it up on MSDN. I know. So if we go to like crypt create hash on MSDN, and then I scroll down, then I can see that this is in advanced API 32.dll, right? Or it's in the WinCrypt header. But if I import, say, advanced API 32.dll here, which I've already done, then it's the enum still isn't in there. So I don't really get it. So maybe I'm doing something wrong, but yeah, if I go to IDA now, and then I go to this address, sorry, I know I'm flipping back and forth, and it might be annoying. And then we get the call here. Then we can see it's CALG SHA-256. So they're making a SHA-256 hash. So then if I add this to my enum, then we'll have it. I know it's ghetto, man. I don't know what to do. Is there a way to explore the imported library? Yeah, so if I go to like advanced API 32.dll, then these there's these crypt hash enums and stuff. But for whatever reason, like maybe those are somewhere else that I'm not familiar with on Windows. You know what I mean? Because if we look in IDA, then like these macros should be in the local types menu. Oh, it's because of the search. So if I do, oops. Oh yeah, and I know in IDA 8.4 they just changed all this. So like I don't know if these are just manually added into IDA and they're not in the type libraries that are being downloaded. But I agree, this is super annoying. Like I think these are just IDA specific. Macro CALG, right? Like why would this be, what is this? Like they must have gotten these constants from somewhere else. Auto-it, good old Qakbot, yeah. Okay, so, but I can do this. But yeah, I agree, it's super ghetto. And I don't really know what to do. But I really wanted to finish this using Binja. So, where's our missing one? Okay, so then we're deriving an AES key using crypt derived key, and then we're so crypt derived key. Where is it? I think is that still just in the CSP? Yeah. So I think it's just and then it creates a key handle. I always forget all of this intricacy between the Windows crypto APIs. So a pointer to hcrypt key variable is received the address of the handle of the newly generated key. Okay, so this is going to be our key handle. And then the address of this variable is used. And then that's used with crypt set key param. So if we go there, I'm just going to move these. PB data in this instance is what? Okay, so let's figure out what it's passing. So KP. Oh man, this is brutal. All right, it is. All right, and then KP mode. Okay, so what was the KP mode? I don't really think this is that important. So, okay, crypt derived key handle, could create hash crypt derived key to our key handle, and then that address is passed, right? And then crypt set param, and then we have our go-to here, which is probably to get last error. So let's name that. And then we have our crypt destroy hash. So this is our hash handle. And then we have our get current process ID. Okay, this looks like it's doing some sort of hashing. And then we're either performing crypt encrypt. Oh, I think this is just getting the size because let's see. So we have the length and then yeah. So this is just getting the length, and then this stuff is calling this. I'll look at that in a second. So this has to do with that value earlier, and then it's calling crypt encrypt again. So what is I7 here? Mode. So I believe, use just a name. So I believe what this is doing is it has both the capability of performing encryption and decryption. Because if we scroll down here, it says else if mode is greater than 16, then we have crypt decryption functionality down here. Here, let me get some different music going. Okay. Crypt decrypt here. So we have the key handle, we have the mode, and then crypt destroy key down here. So crypt decrypt, PB data. Okay, so this is the, I think that crypt set param is important because I think that's setting the, initialization vector for AES. So if we go to, so I actually wanted to try out, let's see here. So if I do so this is Copilot. So if I do something like, this function writes, or this function decrypts data using the Windows C crypto, or cryptography APIs. So then if I do something like function, so there's no telling what it'll give us, but mcryptonet, so those aren't, hold on. But I thought that was pretty funny. So for example, okay, maybe this is a terrible example, but So Sergei on that other stream gave us an example of how to use PE file to extract resources. So like, why does it think it's Swift? Oh, that's why. Okay. So hold on, let me do that again. So if I do like include, and then say whatever, right? So this is all the Copilot stuff. But if I do like and then if I say oh, it's because of my comment block earlier. I'm just too used to writing Python. So if I say this function will decrypt given data using the Microsoft Windows cryptographic API using decrypt. And then I do like void decrypt data. Oh, is that all it's going to give me? I thought it would give me more than that. So if I keep going, come on, write it for me. Yeah, there we go. So, oh, I forgot to say that it's using SHA-256, but using SHA-256 and the AS256 all, then sure. Okay, now it's just repeating itself. I thought it would give me the full suggestion, but anyways, kind of funny, kind of cool. So like if I started rewriting this, so like obviously in ChatGPT you could just start typing out like I want this thing, and then I think this also has a chat function. But so if I did like right, and then crypt create hash, crypt hash data, crypt derive key, right? So it's basically like rewriting what we're reversing. Crypt decrypt. But if I do like crypt set key param, KP mode, yeah, okay. So that's what we were looking for, right? Is this crypt mode? So it's actually setting the encryption mode for AES. So if I go back to crypt set key, then this is G mode, but this is also was it 1, 2, 3, 4? How to get types? Now, I'm just oh yeah, I agree. I don't know. I thought this would be fun to mess around with Copilot. And then this should be 0, right? 3. Yeah, so this is crypt node CBC. If that maps to 1. I should probably double check that actually. Let's see. Prov mode RSA full. Is that it? What? Oh, because I don't have ad block on this browser. Hold on. I'll just put on some music that's not ad ridden. All right. Yeah, crypt mode CBC. Okay. So crypt set key param. So that's setting the mode to CBC, and then where's the initialization vector hit or set? Okay, so we should have a crypt set key param with a KPIV. So this is why like types are so important, is because a lot of these crypto APIs are generic, and I need to know like what they're doing. So man, this sucks. Download the actual header files. Yeah, that's a good idea. So this would be in, it has no idea about imported types. Yeah, the stream will be uploaded, so don't worry about it. Go to bed. I didn't know it was 3 a.m. your time. That's bananas. Yeah, it'll be uploaded to our YouTube channel. So this one, I'll just link it real quick. Sergei, do you know a good place to download the APIs? This is madness. This is madness. We need Binja, yeah. But like, what my question is like, I don't even know if those header files are also downloaded with the type information, because I think the type information might just be used to usually use wine. Okay, cool. Oh, it's WinCrypt. But like, I bet this isn't even going to import, right? Well, I guess we'll just find out. I see you're saying it doesn't work. Yeah. And it could very well be like, I'm on the dev branch and this is 4.0 stuff. So decrypt file not found. Everest, we're basically just needing type like enums for the Microsoft Windows crypto APIs and Binary Ninja, but I can't seem to figure out how to do that. If you can help at all, let me know. So, okay, I think I need to import this one first. Unknown type void. Oh man, this is killing me. No, it's all good. It's all good. Yeah, so like, it would be a types issue, right? Sorry, I'm just trying to see if I can do it this way. Oh man. Okay, I'm just gonna import that KP header so we can just keep going, because I don't really know what else to do. Unless we just finish this in IDA and then automate it in Binja. What do y'all think? But I have to resolve the hash tables in IDA, which would be a pain. Cryptset key param. Okay, I'm just gonna go back to this way. So like, basically I wanted to import the headers from Wine, but then there's a whole bunch of Windows data types that aren't recognized in Binja, so I don't really know what to do. So, okay, so this is the IV. Man, this is crazy. Okay, create types from cstruct. Okay, so I'm importing these. Okay, so cryptset key param kpiv. So this provides the PB data points to the byte array that specifies the initialization vector. So this array must be a block length of 8 elements, or block length divided by 8 elements. For example, if the block length is 64 bits, the initialization vector consists of 8 bytes. So I know based on that blog that the initialization vector a second buffer contains the initialization vector as the first 16 bytes followed by the AES encrypted XOR key. So if we go back here, we can see that this PB data is going to be, so cryptset key param. So PB data is the third parameter. So this is going to be IV and enc XOR key. And this is going to be a struct. So this point is probably that pointer, but it looks like it's getting 16 bytes from that offset, probably, using this function. But again, all of this is being done if these, let's see here. Okay, we'll mark up these other ones too, but luckily we have the types now. But yeah, let's look at what this is doing. Okay, this is a bunch of floating point math stuff. Yeah, let's just call it string length. So how I figured that out was just because it's essentially iterating over this argument variable and then incrementing rex by 1, which is first initialized to 0 until the arg1 dereferences, or while it's not equal to 0. So basically this is like a string length. So it's using this value of behind, and then it's adding a, and it's using this floating point stuff. So I wonder, so there's a bunch of more complex stuff here. Okay, so like this is their encryption functionality. And then they're generating an IV based on this particular algorithm. So let's just say gen data for now. Decrypt. Because this is also used in this function, right? Oh, it's used in a bunch of places in this binary. Okay. Let's keep going. But effectively, this is generating an initialization vector for the encryption function. So this is a good opportunity to see if we can use some of this ML stuff, or AI stuff, I should say, generative AI, to see if it can define any of this stuff. Probably can't, but we'll see. So let's see. All right, so yeah, so just to remind everybody, I got a month of Sidekick, which is like their generative AI stuff. So I'm not very good at using it yet, but let's see if we can get it to analyze this function. Add function comment. The code calculates the value by performing a series of mathematical operations on the input arguments, including bitwise operations. Okay, so not really, and floating point truncation. So that's kind of cool. Okay, so let's just say, and then this is likely a seed for, you got Jordan? Is he here? Hey Jordan, how's it going? You shouldn't be bothering Jordan on weekends. Right, so this was the seed for gen func. And then this is based on the current process ID, blah, blah. So I think this is just the encryption functionality that is seeding the initialization vector using a given key. And that's probably used in a number of other operations. Are the frames dropping for you guys? Or are they okay? It looks like they're. The bitrate just like dropped drastically. Maybe I should restart it with 2500. Use a latency toggle. All right, hold on, guys. I'll be right back because I don't think I can adjust the bitrate live, but we'll see. Did that do anything? Is it still bad? Okay, that looks better. All right. Sorry about that. I should probably just keep it at 2500 for the future, since we've had success with that in the past. Okay, so the next thing we want to do is mark up the rest of these crypt set key param functions. So let's do that. Okay, so this is what we want, right? This is this RSI. So offset to, okay, so this is the XOR key ciphertext because it's the offset IV, and then the, yeah, so the first. Let's see what that block say. Okay, so the IV followed by the AES encrypted XOR key. Yeah, cool. So that's what we're seeing. So the XOR key CT offset. So this is being copied into this buffer, it looks like. And then that's being subtracted on each iteration. Okay. Crypt decrypt is the backside. How's it going? Just call it result. Result XOR key. Okay, so that's just some cleanup function that we'll label for now. Okay, so this returns the XOR key. So the question is, so we know that's what those parameters are, but what arguments are being passed to this? So so the IV XOR CT is passed as the second argument. How y'all doing? You okay? The bitrate okay? The Twitch UI is not like super helpful, but because I think I went from one bitrate to the other, so the graph looks all weird now. I kind of want to see what it says for. Okay, I'm going to use Sidekick on this function. This code is a function that performs encryption and decryption operations using the Windows Crypto API. Okay. It acquires cryptographic context to create a hash that derives a key, sets the encryption parameters, encrypts or decrypts data, and releases the context. Yeah. Sorry, Zog. Whenever I'm saying IV, I mean initialization vector. All right. Good job, Sidekick. So the primary thing I wanted to use Sidekick for is like identifying unknown algorithms. So like that CRC32 function. But I just don't know if it's like contextually aware of like the data that it's referencing, but maybe I'm just not using it properly. Add comment for selected lines. Do you know what I mean? Like if there's reference data, but anyways, let's keep going. So, so yeah, I just wanted to figure out where that, the address of this XOR key CT is. Yeah, so I suspect this Boolean is affecting whether is affecting the mode. Cause see, it's like 1 and 0 and all these different cross references. Okay, I want to see what what's being passed here from like the main function that we were just in. So deal entry. Okay, so XOR CT is arg3, right? Okay, so I think this is it. Cool. All right, so we found the XOR key and initialization vector data. So the encrypted XOR key, and then the initialization vector that's used to decrypt the XOR key. And then, so I suspect there's one of these other buffers that are the AES key. So maybe this one that's, or this is the data, so it's probably the other one. Cool, so let's go back into this one. Just because I keep, see, I did it, never mind. I was like, I keep losing track of which function is which. So this is probably the AES key, I bet. So, but this is hashed, right? So it's not, it doesn't really matter that it's like this particular length, but it is a nice B0 bytes. So if we go to, so if we see, so we should be able to work back up from our crypto APIs here, what data is SHA-256 hashed. So I'm just double checking some things here. So this is the hash handle, but crypt hash data. Oh, this is what we want, not crypt create hash. See, like, I know crypt hash handle makes more sense than crypt create hash, but like they could be the same thing. They could have the same meaning. Pointer to buffer. Okay, so we have the second PB data. Okay. Or so this would be the AES. Nice. So my guess was right. Okay, so now that we kind of understand what's going on, how the AES key is generated, and decrypted, we should be able to test this with our local tools to see if this is just a giant string table or not. And then we can automate it. So, but I do have to run to the washroom again. So I'm just going to run an ad for the Invoke RE course. And then I'll be right back after I go to the washroom. So yeah, this is the course that can let me do all this cool stuff with Sidekick and stuff like that. So check it out. Hey everyone, my name is Joshua Reynolds and welcome to the Invoke RE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you. All right. Hey, Harvest, how's it going? Did you go to Costco again today? Here, let me get that music back on here. Okay. So I'm just going to see if our assumptions are correct about this data. So we can do a couple of things here. So we have the AES data. So what's cool, like this is way better than, this is pretty much what Sergei wrote for IDA, but we can do like copy as raw hex, I think. And then I'm just going to use CyberChef because it'll be easier. Okay, so this is that hex. So I don't know if it's going to copy these null bytes, or it's going to use those null bytes for the hashing too, but I presume they are. Oh, do we have that length actually of, because it should be in crypt hash data, right? The length. Okay. So the DW day length, so it's the third parameter. And then we have arg6, which is probably the ciphertext length. Oh, it might be this mode one. Where's that mode one being set? Okay, let's what's arg6 used for? Crypt decrypt. Okay, plus XOR key length. Okay, and then we have this is like the mode, I think. Is it not? It's got to be used in here. Okay, let's just test out the AES stuff. So we have the AES data length, AES key data length, which is, sorry, I just need to make sure the length is correct because if we hash the incorrect length, then we're going to have a different SHA-256 hash and therefore a different AES key that's used to decrypt the XOR key data. But I think based on the parameters, we can assume that's the case. So we have, there should be one around 165. Let's make that hex, or that is hex, okay. 165B. Yeah, so it's aligned with these 5 zeros, right? And then, so yeah, this is definitely, I haven't marked up any of these yet. Okay. Yeah, let's call this CT, whatever. The more verbose, the better. Then we have the XOR key, CTIV data. Then we have the AES key data. Let's just call it. Okay. And then arg1 is what? Is that constant? So I suspect, and we're going to check in just a sec once we have all the stuff. Do you upload the streams anywhere? Yeah, we or I upload them to our YouTube channel. Let me just grab it. I should really get a bot that I can just like do this stuff with, which I will set up at some point. But here's the YouTube channel harvest. Basically, like all of our socials are under invoke reversing. So if that's helpful at all. I also got Mastodon recently because a bunch of folks are on Mastodon that don't go on X/Twitter, whatever. So, okay, so let's do this AES key stuff and then we'll move on. So like I promise I'm not usually this slow. I'm just really getting used to Binja, so hopefully I can speed things up as I get better with Binja. But okay, and then okay, yeah. So I bet this constant is probably an offset into the strings table, but we will see. So CyberChef. So we actually want, we could probably just script this in, I don't think I have the AES libraries, but we can get all the data we need. So we can do, no worries, I just wasted about 1 to 2 hours yesterday due to failing to hook a versioned symbol in a non-versioned way. Oh, so like it wasn't finding the symbol or something? Oh, my AirPods are dying. Oh yeah, that sucks. So actually in this script that I was showing earlier, I think before you joined. Hold on, I'm just gonna switch headphones. The music stopped. Okay, cool. Okay, so yeah, so in this script that I was doing stuff with earlier, the so on Windows there's these side-by-side DLLs, and then there's also a new DLL since like Windows 7, I think, called kernel base. And these imports that I was using, or that I was hashing earlier, all contain this like stub string. So when I had those stubs in place, then it wasn't resolving the hashes correctly. So I literally just did like an RE sub on like the word stub because of that. So yeah, been there. But luckily I didn't do this on stream, so I didn't really have to suffer through the weirdness. But yeah, let's do that hashing. Or sorry, let's do the decryption with this AES stuff. So probably the easiest way to do this is using the API. So I'll just do, yeah, it should be HLIL. I did it earlier, so let's just go back. Current IL instruction dot tokens. Okay. Right, because it's the current hello IL. Oops, I did not mean to do that. Just trying to pull up the chat in my other window. There we go. Cool. All right, so then we want CT. Shouldn't it be the, it's definitely tokens, but maybe it's because it's the address of a variable. I can't grab it using tokens. Okay, I'm just going to do this manually because otherwise it's going to be a while. So CT is equal to bv.read. And I think this is the length. I don't know why. There we go. Okay, so now we have the ciphertext. Then we'll get the IVXRCT data and that length. And then we'll get the AES key data. So, okay, so the next part is going to be kind of annoying because we need to do, so we need to SHA-256 hash the, I wonder if I have any crypto APIs. Okay, wait, let me actually put this in a scriptlet. And then we'll do, let's just call this AES. And the reason I said this might be kind of annoying is because we basically need to hash the AES. So we need to hash the AES key data. So I kind of want to use the generative AI stuff again for this. So if we do like this function decrypts given data using AES-256. Okay, so like I don't know if I've crypto cipher. Yeah, I didn't think so. But we can install this on our oh, this is so annoying. Because the local Python instance, maybe this has it. Because I know you can do crypto operations within transform, decrypt. Oh, cool. Yeah, it does have. So how do I call this from Binja? Yeah, this might be more annoying than I thought. Okay, let's just try it with CyberChef and then. Yeah, I have commercial Binja. If that's what you're asking. Harvest. Is that stuff? Is that transform stuff not in the regular version? Sorry, I'm just trying to. Okay, so let's get that snippet. Yeah, so the only reason I'm gonna try it first with I'll show you what I'm gonna do. Okay, this is a bad idea. Yeah, I'll just write it in our script here. All right, so we don't really want to do the function hash resolution in the same script, so I'm just gonna write a new one. Okay, so we're gonna do this in our headless instance. I should really make use of snippets more often. Yeah, snippets is pretty good. I'm just not using snippets because basically I keep most of my development environment on this box that I'm SSH'd into here. And I just do that because I don't know, I don't like installing too much crap on my host. So, okay, so this is done. And then we actually want to do, okay, now we can have key is derived using SHA-256 and a hard-coded string. Did somebody ever write this? Did you see that? String Qakbot as the salt. I wonder if this actually exists. Hold on GitHub. Man, AI is wild. No, I don't think so. Like it looked like to me, the AI was getting this from. I thought it would give me the code, but it's not. There we go. All right, AI sucks. It's because this is from some of my other code, so I don't know. All right, let's do this properly. Oh, there we go. Now it's doing it. I just need to figure out what Python library this is so I can install it. Is it PyCryptodome? Okay, from crypto port AES. That's what I did. Okay. So basically, we're just getting the SHA-256 checksum of the AES data. So let's call this AES key data. And then we'll do, then the IV is going to be the key. So we want the first 16 bytes of that XOR key, or that IV XOR CT data for the initialization vector. It's down here. Yeah, the first 16 bytes for the IV. And then we want the next 16 bytes to be the next 16 bytes, or I guess no, just, yeah, the remainder. And we're returning that XOR key. How y'all doing? You all right? Okay. And then how do I make this the nice documentation for work stuff? All right. Ooh, that's cool. I didn't know you did mobile stuff. Okay, let's run this. So I keep getting distracted by things on the left. Incorrect AES key length. But we should have, look at that AI go. 64. Or well, that's encoded with. So what's the deal? I probably have to set the correct AES key length. That's the counter mode. We want CBC. Yeah, looks right. Oh, it's because it's hex digest, so it's the wrong size. Digest. Okay, it looks good. Now let's see what if it's just a straight up XOR with that key. Yeah, so it's kind of what I assumed, where the that constant at the end is the offset into the ciphertext, I think. But is it not XORing it? Or is the actual XOR? You might like this image I generated. Is it gonna exploit my Pixel 8 phone? I love it. Who's the ninjas? Is that you? The VR specialist? It's kind of supposed to be, okay, that makes sense. Yeah, sorry. I'm slow on the references, apparently. All right, constant past. Like, to me, this looks like it's doing, oh, cool. That's awesome. I didn't know you could give it stuff to base stuff off of. I haven't used Dolly since like Dolly 2, so. Okay, let's see what the other calls to this look like. So, I think this looks like, let's see what Sidekick thinks of this. This looks like base 64 to me. Why is it bitrate? Sorry, I keep getting distracted. All right, I was gonna see what Sidekick thinks of this. Add comment, add function comment. This function takes several arguments, allocates memory to the heap. It then performs some operations on the input arguments and stores the result. No, I want you to tell me what the operations are. Because this looks like the, if I can see the whole alphabet, I can say whether or not it's base 64. Yeah, it's base 64. Yeah. All right. Let's stop getting distracted. All right, I'm gonna try just XORing this. If I do XOR byte data. Sweet. Like, this is from my code. So, like, I don't know how Copilot works, because I opted out of using my code snippets, but I'm pretty sure this is exactly my code. Whatever. This is all going to be open sourced anyways, so I don't have to worry about it. And then we have our CT. Yeah. So that was the strings table. I really need a like a hell yeah that Sergei has on his streams. So let's see what's in this strings table, shall we? So we're on the right track, everybody. I know it took us a long time to get here, but I promise I need that hell yeah thing IRL too. Yeah. Yeah, for you guys it would be for the VR guys it would be awesome, because I'm sure you're having, whenever you pwn something, it's like a big hell yeah moment. Okay. I am kind of liking Copilot, to be honest. I know there's a lot of people who don't like it, but split string, no wait, or print. Oh my god, print. All separated. I like using ChatGPT outside of work. Yeah, me too. I don't know what this is doing. All right, let's just do it ourselves, because this is not working. Man, this is kind of overwhelming though. Like, the amount of suggestions is like being blasted at my face. I could probably get used to it though. All right, so let's take a look at some of these strings. Oh, so they're looking for Sentinel one. It looks like Sentinel agent Sentinel UI.exe. They have like some WMI object creation stuff. Sinet. I'm not sure what Sinet is. Spynet. Looks like they're looking for a bunch of different AVs. KV tray. This is Kaspersky AVP. I think they're injecting into word merger. Oh, cool. And then they have a bunch of anti-analysis stuff. So, okay. So for those of you who are kind of new to this, this is why we do this statically, because a lot of malware will have anti-analysis tools that look for, will have anti-analysis functionality that will look for analysis tools. So for example, I don't know if we would have used any of these though, because I don't think x64 debug is in here. The IDA debugger is though. Oops. But like we use Wireshark in the course, for example. So process hacker, P tools, Lord PE, resource hacker. So yeah, there's IDAQ. So I think IDAQ is the IDA debugger. Never heard of Frida outside of Android. Yeah, actually a lot of people use it for malware analysis as well. It's quite useful. I found it to be kind of hard to use because debugging, so I think they go from like the JavaScript UI interface to, I can't remember what engine they're using. Do you remember Harvest? I think they translate, or they have like their API is written in something else other than JavaScript. Their engine is written in something else other than JavaScript. But you interact with it with JavaScript. Anyways. Okay, so that's good. So the next thing we want to do, so we could do a few things. And I thought I said that. So we can do a few things. We can figure out where each of these string offsets are applied. So I'm guessing, like, if we go back here, so this is definitely ciphertext now. This constant is likely the offset of the string. So we could confirm that. So let's go back here. 113A seems kind of high. I don't think there's that many strings. Same with this. So it's probably modified. It's probably like the other one. No, I think it's just straight up pass like that. Okay. So just to give you a heads up, I'm probably going to stop in like 45 minutes. I've been trying to keep these to 5 hours. But But what I am going to do though is I'm going to write all of this up in a blog post that's going to have like all the best findings from this series. Yeah, it is a good chunk of time. I spent like the first hour and a half like recapping and then talking about a bunch of stuff that I did off stream. But yeah, and then I was struggling with some of the type information that I need to figure out in Binja. So once, like, if I hadn't hit those type information hurdles, I probably could have done this faster. But anyways, it doesn't matter. What I was saying was that I'm gonna write a blog post containing all of the like most important things and takeaways from this stream series, and then so all of this will be like nicely condensed and in a consumable format, and kind of showing how to do some malware analysis stuff using the Binary Ninja API. So don't worry about watching the whole like 9. Well, usually these end up being kind of like 2 and a bit to 3 hours once I've cut out everything using editing. So don't worry about watching all 9 hours of this stuff. But having said all that, let's continue on to see if that is indeed the offset. So maybe so this is the ciphertext now. So it's this combined thing that's a little bit weird. Like, why is this being combined with 0? Like, is this literally just interesting? Is the length also encrypted? Or not? All right, let's just see what these offsets look like. And they might just map directly to the correct value. Maybe the strings table is longer than I think. Must be getting the length somehow in this value. Maybe let's look at the disassembly. Maybe I'll look at this in IDA. Just for a sanity check. Yeah, so it's doing a mod. Here's the XOR. Okay, so this is calculating the length. And then the, so that's, yeah, so I'm just naming this the encryption or decryption Boolean, even though I can't see where it's used in this, but I think I'm just missing it. Here it is. Yeah, cool. So that makes sense. If it's not equal to 0, then it performs, if it's not equal to 0, then it, where is it? Then it performs encryption. Then if it's equal to 0, so if it's 1, then it performs encryption, and if it's 0, then it performs decryption. Because this is the entire strings table. So, okay, I think this is the length. There's a lot going on in this function, but basically, this gets the length. This performs the decryption. So let's see what this is doing, or let's see what it's decrypting. So we'll add this to our code. I'm just going to copy this from the other screen. I'll show you what I did. So it's the second and last parameter. So 5AB and 113A. Oh, sorry, Harvest, I just saw your question. How does your work direct samples for you to look at? I've heard of samples getting escalated via SOC process or grabbing stuff off of VirusTotal. Yeah, so I can't talk about it too much, but basically we just look at what's affecting our customers the most, if that makes sense. So most prevalent based on things that based on like a bunch of different data, internal stuff. I'm assuming it's same with VR, like the Pixel 8 being one of the most popular phones. It'd be good to find phones in it. Okay, let's see if this works. So now Pixel 8 is like 3 to 4% market share. Oh, okay, yeah. Yeah, I'm not really, yeah, that's surprising actually. I think they're pretty nice phones. But I guess like Samsung and stuff like that would be way more popular. Could be ported S24 for large. Yeah, cool. Yeah, that makes sense. Yeah, I think we can get rid of this. This AI stuff is pretty cool. I know I keep saying that, but it's just like if it saves me typing time, then I can deal with the blasting. I'm getting blasted in my face. Okay, so this is looking for. I don't know if that's right. Like I don't think the length is right that I used, because these strings don't really look relevant or related. You know what I mean? We could try it dynamically. So we're probably gonna wrap up in like 25. Yeah, let's just check it quick. Is this the... No, this is the old one from last stream. I'm just gonna restore snapshot here. Okay, that's done. So this is our decryption function. So it's using get file attributes. So it should be a file name. But we didn't get a file name, did we? I really want to do this statically. Yeah, but this length is just being modified somewhere. It's definitely the offset. Total length. Let's see what's, let's flip those around. Yeah, it doesn't make any sense either. I'm assuming it's going to be whatever host application it used to load the DLL. So it's just checking that. But what's wrong here? String offset length. Is this being modified? Second parameter. No. It must be this operation, that plus XOR key. I think it's looking through the ciphertext for the constant. C is equal to CT constant offset. So this is just a, so we need the ciphertext. All right, for the sake of time, let's just see what it's, I can figure out this logic later. It's probably not super complicated, but we don't need these anymore. Internal empty. Okay, so we did have the right offset, we just didn't have the right length. So this is right. See if I do, so we could just basically go up to the first null byte, right? Like we could just say, yeah, what's up, Sergei? Oh, cool. So what was I doing wrong? Oh, cool. Okay. So I wasn't completely out to lunch. If it was a bug or feature. Yeah, when I imported it, but the lib is missing them. Oh, okay. So I was kind of right in that like IDA's adding them separately, probably. Well, like I just ships everything, so cool. That's awesome. Yeah, because once that's done, like Binja's sweet. Like I'm gonna keep daily driving it, not daily driving it. Sorry, I'm gonna keep using it on stream and stuff. Let's see. Okay, so just for funsies. Okay, cool. Nice. Thank you for doing that. I really appreciate it. And thanks, Jordan. I don't know if you're listening, but if you see this later. But like, yeah, I am using the dev branch, so it's kind of to be expected. Okay, I kind of want to see what Sidekick says for this one. Sidekick. Yeah, thanks, Jordan. I really appreciate it. But I think, oh, don't worry, man. Don't apologize. This is good QA on the dev branch. So otherwise it's been super stable, for the record. Okay, so add function comment. This function decrypts a given ciphertext using AES and the XOR key and returns the decrypted data. Yeah, like that's correct. Hell yeah, Sidekick. I was also going to try Sidekick with the struct stuff. Probably not today because we can do that in another stream, but yeah, it's cool. I just I got my like first month this morning, so I still have like I was messing around with some of these suggestions, but I think I'll probably do like a full Sidekick stream where I use it with malware rather than me shoving it into this week's. But you can already see it's like base64. Like, what is this? Oh, okay, hold on. I'm going to go on a small tangent. I want to jump to that. No, where was that? 1800161F4. I think that was the one that I was trying to, that I knew was base64. Yeah, I think I'm good right now. Well, actually, while I have you, is there a way for me to jump to this function address from the suggestions pane? Because I do want to apply them, but I want to look at the function first. I thought double clicking it. Oh, maybe I just, oh, there we go. I just had to click on one of the items in this subfunction. So this is, oh yeah, this is the base64 function. So let's apply these. Look at that. This is basically what I wanted. Okay, and then if I get this to recomment it, is there a faster way for me to do it than with this menu? Apply, add function comment. See, and then now it knows that it's base64 in the function comment. You can bind it to a hotkey, but not by default. Okay, cool. I'll do that. Oh, cool. Okay. Yeah, I'll create some custom hotkeys for these. Cool. So yeah, I'm definitely going to try this. Okay, I want to try it on the CRC32 function real quick. Or let's do a DLL entry. And then resolve function table. Okay, so I just applied. Man, this is sick. A function pointer by searching the corresponding function name for the export directory to the given module. If it is not found, it attempts to load the module and retrieve the function pointer. Also, if you find it being a bit too obnoxious with suggestions, you can increase the dwell time. No, I think the dwell time is pretty good actually by default. Cool, but that's good to know. I'm also messing around with Copilot, and that's super obnoxious to program with. But no, this is pretty chill, actually. 10 pointer, yeah. Oh yeah, so I wanted to go to the actual hashing function, which is where malware hash data. Oh, another thing that might be helpful in the suggestions menu is like a little search filter that I can apply, like similar to like this one. So then I can just search for like this MW hash data function, if that makes sense. I don't know if you guys have thought about that. MW crypt decrypt, MW hash data, recover defined structure types. Sure, let's see what it does. Okay, so I was hoping that it would find the hash data. I think it's supposed to focus on the suggestion relevant to the function. Oh, cool. Okay. Cool. Okay. So I'm just going to keep applying these because it seems to be doing cool stuff. Hash data, hash value, resolved functions. Oh yeah, I need to sort this one out too. Yeah, but yeah, this is super cool. I might do, because this is kind of obfuscated, but I feel like when I do a Sidekick stream, I will use like a piece of malware that is pretty like plain text or like straightforward to reverse, and I feel like Sidekick will just like slice through like a hot knife with butter or something. Some analogy that makes sense. But yeah, with like this is obfuscated stuff and it's still working well. So clean up heap memory if argument is not empty string. Pointer to value. Name callee function names. Yeah, so like this stuff is like a huge time saver, right? So callee decrypt data. Oh, okay. Yeah. But yeah, like if I can like automatically propagate arguments and stuff, I think that's what that means, right? Or well, that's just the function name, but hold on, I just want to, okay, let's just do more Sidekick stuff and I can I can finish the string decryption stuff offline because it's kind of boring. So let's look at some of these function tables. So then let's go to like that registry one was pretty interesting. Or like this C2 one. I bet this will mark up the C2 one really nice. So like internet close data. Let's try this. 6.4. Oh, it does show you the current function. Yeah, I missed it too. But after you said it, it made more sense to me. So, okay, these functions are missing. So it's probably something I need to fix. Oh, did it just? I think it might have just messed up the, yeah, it messed up my function hashing. That's okay. That's why they're optional suggestions. Okay, let's just get it to suggest. Yeah, I just undid it. So now you can see they're showing up again. Okay, internet close handle. Hold on, I think there should be some better internet read file. I bet this will be good. 149. Oh yeah, here we go. Recover and define structure type supply. I wonder if this will kill my function hashes again. Yeah, it did. All right, well, yeah, this isn't really a good sample for this. But let's get it to summarize this, because it'll basically say, I suspect that it's reading data from the command and control server. Or well, not, it won't say it in that sense, but you can move xrefs to the right side now too. I've been rocking Sidekick that way lately. Oh, cool, okay. Like unpin it? Yeah, cool, okay. And then, can I get rid of it? There we go. Like that, right? Oh, did I do it right anyways? Even though I just did it a weird way. Pinned cross references. Oh yeah, you can move it to the pane. Oh, cool, okay. But I mean, just moving xrefs. Yeah, like this is way cleaner. Well, I guess now it's disrupting the disassembly a little bit. But I guess you mean putting it like down here, right? Maybe I'm not doing it right. Anyways, let's see what Sidekick says about this guy. Am I blind? Where's the add function comment? There we go. And for the record, I am kind of blind because I usually wear glasses. And that font is tiny. This code reads data from the internet and stores it in a buffer, which is dynamically allocated based on the size of the data. The function returns an error indicating the success or failure of the operation. Cool. Okay, let's see what else. Here, I can actually open like, oh yeah, totally. Okay. Yeah, I'll use the command palette. That's a really good idea. Let me open, I'm just gonna open a sample that's easy to analyze. All right, this should be easier. So see, it has nice debug information, whatever. So like this decryption function, if I wanted to understand it better. Okay, yeah, Sidekick is there. I'm just gonna pull up chat. Okay, now there's suggestions. Input. All right, let's see what it says about this function. And I'll use the command palette like you just said. Add function comment. This code decrypts the input string by subtracting a character. Yeah, this is awesome, man. Look at that. And I already decrypted all these, so that's why they're plain text in this database. But say we go to like check AV. This code checks for, this code checks for the presence of various antivirus software by decrypting their names and then checking if the corresponding path exists. The result is then stored in var 8. Like AV check result variable. Like that's so cool. I had to write some code. It didn't do as well as I was hoping, though. Yeah, that would be sick. So like if I go to the notebook, like do I just type in, sorry, I really should have read all the manuals before this, but I was just looking at it this morning. You should navigate to that function first. Right, okay. Okay. And then I can just say like, can you in Python? Or am I using this wrong? Try it. Oh, it's thinking. It's thinking. Yeah, legitimately don't know. Dude, this is so cool. It actually just did it. So if we can actually compare it to my snippet. So hold on. Mine's more complicated just because it's like literally replacing the strings that it's decrypting. But let's I'm gonna put this in an editor and then we can side by side it. And I really like that it has markdown, like literally in the. It should know the BN APIs as well. Okay, hold on. Let's do this first, and then I'm gonna try that. This code is probably even better than mine because. So binary reader, CBI. Yeah, it's basically doing the same thing. Okay, now I'll say, can you, I don't know how to phrase it. So is it contextually aware? Like, will it maintain the current conversation? Holy crap. So if I do like, can you write this function so that it will decrypt all data passed to it with the Binary Ninja API? Probably have to ask. Oh yeah. Okay, yeah. So can you this or decrypt all data passed. I don't know. Yeah, okay. I'm gonna use your, I don't know how to phrase this. Can you place all the locations where this function is called with the decrypted results? Yeah, I'm not really good at prompt engineering. Like, I wonder if I don't specify the Binary Ninja API, if it'll be like, I don't know. Let's just see what it does. Yeah, okay. So I'll say that again, but I'll say with the Binary Ninja API. Can you show me how to decrypt all You forgot to ask it to output Python. Yes. Did I say that earlier? Oh yeah, I did say that earlier. So I wonder if it'll know based on the context mishap. Caller addresses. But did it get the correct caller references? Because that would be really cool. Wait. Yeah. that's what I'm checking. No. These are just random like starts of other functions. It does call it. Oh, because they're the actual, but it's just not the call locations. I saw a decrypt in both of those. Yeah. Okay. Let's say the same thing again. Man, if it's like contextually aware of the entire database and I can write automation using this, like this is actually game changing. Cross references to this function. Call locations to this function. Oh yeah, I should call them call sites. Sorry, I just saw your chat now. You shouldn't even have to say BN using BN API. So the only reason I said the add other callers as needed. Don't be lazy. Let's see if. Weird. It's funny. Yeah, the only reason I said using the Binary Ninja API is because it said To replace all locations, you will need to do the following. Identify the it wasn't giving me the answer relative to the Binary Ninja API, if that makes sense in this one. Exactly. Okay, I'll put in what you said. I'm trying to copy the chat text and it's not working. You had to ask for code. You told it to show you that prompt. Okay, I'm going to use Mishap's prompt. I'm glad I have real prompt engineers on stream to help me. We should do, I don't know how we would do this, but what would be a really good Twitch stream is like Twitch chat reverse engineers malware, and then we can just have you guys write prompts to like do shit. Twitch plays Pokemon. Yeah, exactly. Ooh, this looks good. Get function by name. Target function. Get code references too. Yeah, I think Mishap cracked the code. Implement decryption logic here. Boo. It did like one part, but not the other. It already had the other part. Did it? Did I miss something? Oh, I see what you're saying. Yeah. I think it encrypted arg address. I think it did that. See, it's because it's bv.write encrypted arg address, decrypted string. Yeah. Dude, this is sick. I haven't been this excited about like anything in a while. Yeah, no worries. I think we'll do like a full Sidekick stream. So thanks for joining and looking into that stuff with Sergei. I really appreciate it. Yeah, like it just did it. So yeah, I'm in the Binary Ninja Slack. Yeah. I think I'm under my handle. I'll double check, but yeah, I'll just ping you on Slack. All right. Well, later. Have a good weekend. Yeah. So it's like streaming like ChatGPT. That'd be cool. Okay. So we'll probably wrap it up there. What I will do though is finish this string decryption. Or wait, not this one. What I will do is finish this string decryption functionality, so it will decrypt all references to the string table and then print those out. And then we didn't find the C2, the embedded C2 functionality, or the embedded C2 data rather. So I'd like to do that as well. But I think I'm just going to keep all of that for the blog post, just to wrap things up. So we're not spending another stream on this sample. But yeah, hopefully that was entertaining. I'm just going to run one more ad before I go, just because that's what's supporting these streams. We do malware analysis training, so training.invokere.com. And we have a course called Introduction to Malware Binary Triage. If you want to check it out, you can look at the first few modules for free. And if you want, you can join our Discord as well. There's a link there on this website. There's the link to the training. So that supports all these streams, let us use cool stuff like Sidekick, and pays for my Binja license and a bunch of other stuff. So yeah, if you want to check out the course, that'd be really cool. And I'm just going to run an ad for that real quick before we say goodbye. So see you in a sec. Hey everyone, my name is Joshua Reynolds, and welcome to the InvokeRE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you. All right. Well, that's it for today. As always, I'm going to upload everything that I worked on, all the source code and everything to our GitHub, and I'll link those in all the areas that we usually link them. But thanks a ton for joining and supporting us, and I'll talk to you later. I hope you have a great weekend. Take care.